Hello everybody, we are going to start the chapter first. It's name called Chemical Reactions and Equations. Here at the top it's written facts are not science, as the dictionary is not literature. It's written by Martin H. Fisher. Here we go at the bottom side. It says, consider the following situations of daily life. Okay, it means you have to assume the following situations of daily life and think what happens when milk is left at room temperature during summers. Oh, milk gets sour in taste. Yeah, okay. An iron tawa or iron pan or iron nail is left exposed to humid atmosphere. What happens with it? Okay, iron tawa, pan and iron nail, so it gets corrosion, and the specific name of that iron tawa pan nail corrosion name called rusting. Okay, grapes get fermented. Okay, food is cooked. Okay, so what are the like chemical reactions happens, and what are the scenario like food is getting cooked and food gets digested in our body by which reactions, and how do we respire. Okay, so these kind of scenario, like you have to like consider in day to day life what happens with this. In all the above situations, okay, the nature and the identity of the initial substance have somewhat changed. Yeah, that's correct, it's somewhat changed just because in milk, in summer what happens, it's get sour in taste by like 6 to 7 hour duration of time. Milk gets sour, and when we exposed an iron nail, iron rod into the humid atmosphere, okay, it gets corrosion, and the specific name for iron corrosion is rusting. So these are the changes happens. We have already learned about physical and chemical changes of matter in our previous classes. Okay, that means you are already studied in class ninth, but we are going to move ahead. You are in class 10th, so you are going to further understand in more details over here. So let's go over ahead to here. Whenever a chemical change occurs, we can see that a chemical reaction has taken place. Okay, okay, we can understand. Always there's a chemical reaction take place. You may perhaps be wondering as to what is actually meant by a chemical reaction. Yeah, is it so? Like, what is chemical reaction? We should have to learn about this. What is chemical reaction? Here, how do we come to know that a chemical reaction has taken place? Okay, let us perform some activities to find the answer to these questions. Here, we see over here in the figure 1.1, it says burning of a magnesium ribbon in air and collection of magnesium oxide in a watch glass. Okay, we are going to notice what are the points written over here. It says at the lowermost point it says burner, and then tongue, and magnesium ribbon is holded by tongue, and this is a watch glass, and magnesium oxide is present in the watch glass. Okay, so activity 1.1, it says caution. Okay, so it's at the initial point, it's giving you a warning. Okay, so what's the warning point? The warning point is this. It says this activity needs the teacher's assistance. That it means you have to be very careful, and you should have to go with your teachers. Without your teacher, it's going to be a little dangerous for you, so you have to take assistance of your teacher, because they already know about their consequences. So you should have to take assistance of your teachers. Okay, it would be better if students wear suitable eyeglasses. Yeah, you should have to wear suitable eyeglasses, just because your eyes are very very important, and you don't have to lose your eyes, or you have to damage your eyes, because these are some of the thing is drastically changed within a few seconds. So you should have to be very very careful about this. Clean a magnesium ribbon about 3 to 4 centimeter long by rubbing it with sandpaper. Yeah, but why we are doing it rubbing with sandpaper? The reason being first is like there is some of the layers is accomplished on the magnesium river, so that's why we are rubbing it with sandpaper, and there is no other layer is present on magnesium ribbon. So we have to make the activity separately wonderful, and what we expected to get the result. So okay, we are moving ahead. It says hold it with a pair of tongs. Okay, tongs. Held it with a pair of tongs. Burn it using a spirit lamp or a burner and collect the ash. So formed in a watch glass. So, watch glass as shown in figure 1.1. Okay, burn the magnesium ribbon, keeping it away as far as possible from your eyes, because I said already that your eyes are very precious, and like you are doing it by sincerely, that it means you are looking it very very careful, with your so much attention, paying attention to it. And in these all kind of activities, by some mistakes, uh, if there is a problems comes to your eyes, or like the thing that you are doing it in your activities will going to harm you, if some of the dangerous activities get performed by accidentally. Okay, what do you observe? Okay, so what do you observe? Here it is an answer. It says you must have observed that magnesium ribbon burns with a dazzling white flame, with dazzling white flame, brother, and changes into a white powder. And what is a white powder? That white powder is a magnesium ribbon ash. Okay, this powder is magnesium oxide, dude. This powder is magnesium oxide. And what's the color of the magnesium oxide? Give me an answer. What's the color of an of magnesium oxide? It's white, or you can say colorless. In the regard of color, I can say like there is no color. White and black are scientifically, they both are no color, because a combination of colors forms white light, and black color doesn't exist. Just reason being, absence of color is called black color. So scientifically it said white color and black color are not colors. So if you're in the question, it asked like, so what's the color of the magnesium oxide when we want magnesium in the presence of oxygen? So what's your answer? It's colorless or white. Okay, colorless or white is the same thing. It is formed due to the reaction between magnesium and oxygen present in the air. Okay, here activity 1.2 and activity 1.3. Okay, so we are going to read over here. In figure it says figure 1.2, formation of hydrogen gas by the action of dilute sulfuric acid on zinc. Okay. Okay, we are going to see this figure. It says one of the flask is over here, one conical flask, and dilute sulfuric acid is over here, zinc granules present at the bottom of this conical flask. Okay, and here hydrogen gas is going upward in direction, and there is a glass tube, and here it is a cork. Okay, so what's the role of the cork is there is no passage of air and something any material through it. Cork, by cork, because cork, like in badminton cork, they are made up of rubber. So here it is the same thing. This cork is also made up of some of rubbers, some specific kind of rubbers, so to do not allow other kind of exchanges through it. And in between the rubber cork there is a glass tube meant for to pass the hydrogen gas and collect the hydrogen gas. And you can observe hydrogen gas by like, okay, at the top of it, if you like just have to put a lighter to it, this hydrogen gas going to be burnt. Okay, so okay, from the above three activities, we can say that any of the following observations help us to determine whether from the above three activities. Okay, so we have to read activity 1.2. It says take lead nitrate. Lead nitrate. Okay, so what is lead? Lead is Pb, and what is nitrate? Nitrate is NO3. So lead nitrate, the lead present in our day to day life with Pb plus 2 and nitrate NO3 nitrate NO3 2 minus. Lead nitrate, lead, 1 minute, lead nitrate, lead Pb plus 2 and NO3 minus, nitrate is NO3 minus. Okay, so lead nitrate Pb NO3 twice. Solution in a test tube and add potassium iodide solution to this, Ki, potassium iodide. And how potassium iodide it formed? Potassium, okay, and and iodine, I minus, iodate ion, in the combination of potassium and iodine it forms potassium iodide, potassium iodide. Solution to this, what do you observe? So you observe it's a double displacement reaction. You have to note it down on your books, or yeah, you just have to write it down over just at the bottom side. Okay, what do you observe? So you observe double displacement reaction by how? By like lead nitrate PbNO3 2 plus Ki forms what? Lead iodide. Double displacement reaction. So okay, lead iodide is formed and potassium nitrate is formed. Lead iodide is a bright yellow color precipitate, and lead nitrate, so what's the color of the lead nitrate? Lead nitrate is a colorless, and that means white in color, lead nitrate. And potassium iodide, okay, it forms potassium nitrate plus lead iodide. Lead iodide is bright yellow precipitate. It's okay, so that's it. And activity 1.3, it says take a few zinc granules in a conical flask. Okay, activity 1.3 and figure 1.2 is the same conclusion over here. Okay, it says take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid HCl or sulfuric acid. I'm going to tell you one thing. Hydrochloric acid is the strong acid, or sulfuric acid is also the strong acid. So you have to understand this HCl, hydrochloric acid, their short form, that means like in symbolic form it's written HCl, and sulfuric acid, their formula name is called H2SO4 to this figure 1.2. And caution is over here, it's written, that means you have to be very careful. And what's the like we have to care about, the thing is, handle the acid with care. Yeah, because these are acids, and this will going to hurt you, so you have to be very care, because these are very like dangerous for you, for your body. So handle the acid with care. Do you observe anything happening around the zinc granules? Yes, yes, we are observing something. Touch the conical flask or test tube. Okay, is there any change in its temperature? Yes, it's a exothermic reaction. Zinc plus sulfuric acid, H2SO4, zinc plus sulfuric acid, it forms zinc sulfate, plus it forms H2SO4 and zinc. Hydrogen gas, it involves also hydrogen gas. So hydrogen gas is a like what, um, hydrogen gas is a flammable gas. This will going to be want like this is exothermic. Okay, this reaction is exothermic reaction. So you feel heat, you feel a little high temperature by touching of the conical flask. Okay, from the above three activities, we can see that any of the following observations helps us to determine whether a chemical reaction has taken place. From the above three activities, we can say that any of the following observations help us to determine whether a chemical reaction has taken place. Yes, by change in state, change in color, evolution of a gas, change in temperature. Yes, yeah, let's go. Like zinc granules is a solid, okay, and it forms with reaction with sulfuric acid, it forms zinc sulfate, which is an aqueous solution, as well as creating hydrogen gas. Okay, so this is change in state from one solid and one aqueous solution forms one aqueous solution and one gaseous solution respectively, as what I said, said it over here. As well as change in color. Yeah, evolution of a gas, and change in temperature from no temperature raise in the very first time, but after this reaction temperature raises high, or temperatures increases. As we observe the changes around us, we can see that there is a large variety of chemical reactions. That's very, very true, taking place around us. We will study about the various types of chemical reactions, okay, and their symbolic representation in this chapter. Okay, so what we are going to study, we are going to study for various types of chemical reactions as well as and their symbolic representations in this chapter. So we get ready, bro, just let's go. So it says 1.1, it says chemical equations. So we are going to study chemical equations. So are you guys ready? Yes, let's go. Activity 1.1, it says can be described as when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. Yeah, that we know, because one in the first activity it says magnesium in the presence of oxygen it forms magnesium oxide. Of course we know about this. This description of a chemical reaction in a sentence form is quite long. it can be written in a shorter form. Wow, that's the great thing, and that's the good one, because that long one becomes into a short one. That's so good, and that's the incredible thing. The simplest way to do this is to write it in the form of a word equation. Wow, that's the great in the word equation. So let's we go over here. It says the word equation for the above reaction would be what? Would be what is magnesium plus oxygen, okay, forms magnesium oxide. So in the left side you have observed magnesium plus oxygen, they are called reactants. Wow. And at the right side you observed magnesium oxide is a product. So what are the reactants over here? Magnesium plus oxygen are reactants. Correct answer. So what's the product over here when magnesium and oxygen burnt? Yeah, what's the product? Yeah, magnesium oxide. That's correct. That's like a good boy. Now we are going moving to the ahead to the next one. It says the substances that undergo chemical change in the reaction 1.1 1.1 reaction. Okay, magnesium plus oxygen makes a magnesium oxide. So this is the reaction. Magnesium and oxygen are the reactants, as what I said earlier. The new substance is magnesium oxide. Yeah, we all know about this. Formed during the reaction as a product. Yeah, a word equation shows change of reactants to products through an arrow placed between them. Oh, so here it is. You focused over here. There is an arrow in between reactants and product. One arrow. This is at the, you know, at this arrow pointed over here, pointed towards on the right direction, their head. Okay, their head tells about the product, and their tails of the arrow tells about the reactant. Okay, from which side, from their side it going to be forms. Tail represents reactant side, and the head of the arrow represents product side. That means forming a product. So okay, we are going to move further. It says a word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left hand side. That's called LHS. Or okay, at the LHS side it's called reactant with a plus sign between them. Okay, with a plus sign between them. Okay, yeah, here it is a plus sign between the magnesium and oxygen. Here it is two reactants. Here at the reactant side two things are present, magnesium and oxygen. So we have to write with plus. Oh, okay. Hmm. Similarly, products are written on the right hand side RHS with a plus sign. Okay, between them. Okay, but here at the product side just magnesium oxide is formed, so there is no plus sign, just because it's absence of another product. But at the here over here, like at the double displacement reaction, what like here it says lead nitrate plus potassium iodide, it forms lead iodide and potassium nitrates. So here at the product side two things are formed, as well as at activity 1.3 it says also, like zinc plus sulfuric acid forms what? It forms hydrogen gas as well as zinc sulfate. So the plus is also present in this reaction. Okay, we all understand this. The arrowhead points towards the products. Yeah, we all know because I already told you. And shows the direction of the reaction. Okay. The arrowhead points two things, which is arrowhead points. What are those two things? That it shows it forming the products, as well as the arrowhead point out the products as well as the direction of the reaction, in which direction reaction is occurring to the right hand side, reaction is occurring to the forward side. That it means writing a chemical equation 1.1.1. Okay, is there any other shorter way for representing chemical equations? Is there any shorter way for representing chemical? Yes, by symbols. Chemical equations can be made more concise, means more short and useful, more short or more small and useful if we use chemical formula instead of words. Yep. Like you don't have to write water, you have to just write H2O, 3 just involves 3 letters. Okay, so you don't have to write sulfuric acid, you have to write just H2SO4. Okay, a chemical equation represents a chemical reaction. A chemical equation represents what? So, what a chemical equation represents? This is the question. Tell me, what a chemical equation represents? A chemical equation represents a chemical reactions. That's the good answer. Okay, if you recall, okay, so you have to recall formula of magnesium, which is Mg, and oxygen, which is O, and magnesium oxide, which is MgO. The above word equation can be written as what? It's written as Mg plus O2 forms MgO. But here it says magnesium Mg and oxygen O. But why in the reactant side we write O2? Because oxygens is present at the very large amount in this our earth with in the form of O2. So that's why we write oxygen O2 over here at the reactant side. Count and compare the number of atoms of each element on the LHS and the RHS of the arrow. Is the number of atoms of each element the same on both the sides? Answer is no, because magnesium at the left side over here, if you look at this figure here, this example, it says magnesium is 1 at the left side, at the right side magnesium is 1. That's correct. But is that true that oxygen and present at the left side and right side are equal? No. Oxygen at the left side, they are 2 in number, but at the right side oxygen is just 1 is present. So this reaction is not balanced. So we should have to balance this chemical reactions. Okay, if yes, then the equation is balanced. If not, okay, if not, then the equation is unbalanced. Yes, this equation is unbalanced. We should have to balanced, unbalanced, because the mass is not the same on both sides of the equation. Yeah. So why this is if this is not balanced, then what is it? Equation is unbalanced because the mass is not the same on both sides of the equation. So what about mass? Like, atomic mass, it means magnesium atomic mass is approx 24. Oxygen here, O2 is here, their atomic weight is 32, and 32 plus 12 24, it forms different as well as that means the sum of what is it, where is the pin, where is the pin, where is the pin, here I got it. So mg24 plus 32, it forms 56. Atomic weight is 56 at the left side, and at the right side MgO is here. MgO is atomic weight, Mg is 24, oxygen atomic weight is 16. So it forms 640213140. So the atomic weight is not balanced at the left side and at the right side, it's not equal. So we should have to balance. But why we are going to balance the atomic weight? Because our science, it says like uh, here it is all talking about universe. Science talks about universe, and in the universe there is no creation and no destroyation. Okay, so we don't make things, and we do not like we can't form and we can't destroy. So this is like the laws of universe, it says by scientists. So okay, so we should have to balance the chemical equation to balance the atomic weight, to balance the atomic mass. Okay, so over here it says if not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Okay, that's fine. Such a chemical equation is a skeletal chemical equation for a reaction. Yup. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in a. Okay, that's called a skeletal chemical equation. So that chemical equation is a skeletal. That means it's a all a structured form. So that's we call it's a skeletal chemical equation. This chemical equation is a skeletal for the burning of magnesium in air. Okay, balanced chemical equations recall the law of conservation of mass that you studied in class 9. Mass can neither be created and neither be created nor destroyed in a chemical reaction, dude. What happens in a chemical reaction? There is nothing we create and nothing we can destroy in a chemical reaction. That is the total mass of the that is the total mass of the elements. Hey, just wait for a second. Here, okay, let's go. Recall the law of conservation of mass that you studied in class 9. Mass can neither be created nor destroyed in a chemical reaction. That is the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. Okay, that means you should have to totally understand like there is you should have to balance the chemical equations to just to make sure there is no like unbalanced atomic masses. So yep, we have moving forward. It says, in other words, the number of atoms of each element remains the same before and after a chemical reaction. Yeah, each element remains the same before and in other words, the number of atoms of each element remains same before and after a chemical reaction. Okay, hence we need to balance a skeletal chemical equation. Okay, that it means if you have to balance the chemical equation, you just have to make sure to like you have to
like you have to balance the chemical equation, or you have to balance the atomic mass. You have to do one thing, you have to just balance the atomic number of atoms of each element. You have to what you should have to do, you have to balance the number of atoms of each elements. Okay, that's it, that's it. Is the chemical equation 1.2 balanced? Chemical equation 1.2, where it is 1.2? Oh, balance. Oh, so this is talking over, oh, talking about over here. No, this is not balanced, dude. No, answer is no. Let us learn about balancing a chemical equation step by step. Okay, here we go. The word equation for activity 1.3 may be represented as zinc plus sulfuric acid. It forms zinc sulfate plus hydrogen. Yeah, same is the activity over here 1.3. Over here, this conical flask over here at the activity 1.3. So, all these activities talking about over here, and it says zinc plus sulfuric acid forms what? Zinc sulfate plus hydrogen. Wow, great. The above word equation may be represented by the following chemical equations. Okay, but you know why this reactions happens? I'm asking you a one question, why this chemical reactions happens? The answer is this chemical reaction happens just due to sulfuric acid is a strong acid, as well as the zinc. This zinc is very what I say, like this zinc is very aggressive in nature. That's why zinc is like uh, in this situation of to fight with somebody. Okay, so this zinc is very aggressive. That's why zinc displaces the hydrogen from from sulfuric acid, and itself it forms zinc sulfate, and replaces the hydrogen. Okay, and you know what happens, sulfuric like what are the reasons sulfuric acids how they are sulfuric acid formed? So how sulfuric acid formed? Their answer is like hydrogen plus sulfate ion. What is sulfate ion? SO4 2 minus. SO4 is okay, and 2 minus at the right upper side of SO4. Okay, 2 minus. So 2 minus is present at the right upper side. Okay, that's it. And it forms as sulfuric acid. So at the water, so after the zinc addition, zinc displaces the hydrogen from sulfuric acid, and zinc forms zinc sulfate plus hydrogen. And how this happens? Just because zinc is aggressive and fighting nature, that can replace the hydrogen as more powerful than hydrogen. That's why zinc replaces the hydrogen. Instead of zinc, if silver is present plus sulfuric acid, then this condition will not going to be occur like zinc sulfate plus hydrogen. No, the reason being silver is not very aggressive in nature, not fighting nature, that can displace the hydrogen from the sulfuric acid. So, and the next example is gold is also a very gold is also less aggressive, very less aggressive. Okay, even less aggressive than silver, that cannot displace the hydrogen from sulfuric acid. Like you like if I placed at the place of zinc, put I should have to put over here gold, then gold plus sulfuric acid, it forms gold sulfate. No, no way, it forms just sulfuric acid plus gold. That means no reaction. Yeah, same thing at the left side, the same thing at the right side, the same thing. That means there is no reaction. Why it happens? Because Gold do not have that property, that activeness in of their self, that can displace the hydrogen from sulfuric acid, because hydrogen is more powerful than the gold and the silver. Okay, you understand this? So okay, the above word equation may be represented by the following chemical equation. Okay, zinc plus H2SO4, it forms ZnSO4 plus H2. Yeah, zinc is their symbolic name is Zn, and sulfuric acid, their formula name is H2SO4. Okay, here it is a H2SO4, sulfuric acid is a compound. Okay, zinc sulfate, ZnSO4, zinc sulfate compound name is over here zinc ZnSO4, and hydrogen H2. Okay, two atom of hydrogen. Let us examine number of atoms of different elements on both sides of the arrow. Okay, we are going to examine the number of atoms of different elements on both sides of the arrow, at the left side and at the right side. So okay, at the over here it says at the element side zinc, hydrogen, sulfur, oxygen. Okay, number of atoms in reactants, or you can say at the LHS side, zinc is 1. Okay, zinc is 1. So at 1.3 activity it says zinc is 1 at the reactant side, as well as the product side zinc is 1, that is balanced. Okay, no problem. But at the but in the chemical balancing, you should have to balance all the elements. Okay, hydrogen, at the left side there are 2, and at the right side hydrogen is remain 2, so that's okay. And at the left side sulfur is 1, and at the right side sulfur is 1 again. Oh, that's great. So it is also balanced, but we should have to check all of them, like which is unbalanced. If this equation is balanced, then there is no problem, we do not have to balance this equation. Okay, over here oxygen, at the left side there are 4 oxygen, and at the right side there are 4 oxygen too. So we do not have to balance this chemical equation, they are already balanced, dude, over here. As the number of atoms of each element is the same on both sides of the arrow, equation 1.3 is a balanced chemical equation. Yeah, okay, that's fine. Okay, we all get it. Let us try to balance the following chemical equation. Iron plus H2 forms Fe3O4 plus H2. Wow, that means iron present in the iron rod. You just take an example of iron rod present in one full of bucket of water. It forms rust plus hydrogen gas. So over here, the rust formula is this Fe3O4 dot NH2O. you know so why this is written like the rust formula is little bit different over here, uh, just because it takes one water, so that's it forms just Fe3O4 and no other H2O attached with it. So okay, and Fe3O4 NH2O, N representing number of waters. So okay, if he like over here at this time it says like iron is present at very minute amount, and water is also present at very minute amount, and it forms a rust with no water plus hydrogen gas. Just if iron is in excess and water is in excess, then their formula it becomes, and then their product it forms Fe3O4 and NH2O as well with attached to it. Okay, and some other like H2. Okay, some maybe H2 or maybe not H2. Okay, okay, you got it, I think. Step 1 it says To balance a chemical equation, first draw boxes. Okay, around each formula, do not anything inside the boxes. Okay, you should have to, like, you do not have a permission to change inside the boxes while balancing the equation. Okay, Fe plus H2 forms Fe3O4 plus H2. Okay. Step second is saying that list the number of atoms of different elements present in the unbalanced equation 1.5. Okay. Element iron, hydrogen and oxygen. What's the name, what's the symbol of iron is Fe, and what's the symbol of hydrogen is H, what's the symbol of oxygen is O. Okay, but you have in chemical reactions you write it down O2. Why? Because oxygen is present in natural or in general format in O2 form. That's why they represented about their forms. And some of the questions you get it like, and like hydrogen is present in H2 form. Why? Because the form of hydrogen that exist in nature in very often in H2 condition. So that's why uh, H2 is present at this uh, example over here, Fe3O4 plus H2. Number of atoms in reactants at or you can say LHS. Iron is 1 at the LHS side, and iron is 3 at the right hand side, and hydrogen, so this is unbalanced chemical equation. If you get a one unbalanced atom, okay, that means the whole chemical equation is unbalanced. Iron, okay, hydrogen is 2 at the left side, but hydrogen is, oh, again 2 at the right side. There is no unbalanced between hydrogen, but this total equation becomes unbalanced just due to one unbalanced atom. Oxygen at the left side, here it is 1, and at the right side oxygen numbers are 4 in number. Oh my god, so we should have to balance. Step 3, it says it is often convenient to start balancing. Oh, often convenient. That means you have to do balancing first with the compound. Okay, that contains maximum number of atoms. So in this compound, uh, in which compound? Okay, Fe3O4. This compound contains maximum number of atom of oxygen and then iron. Okay, so we should have to balance this equation. I started first with oxygen. Then after balancing the oxygen, we move to the maybe iron or maybe to the hydrogen. Okay, here we go. It may be a reactant or a product. There is no other, like, we don't have to make it which is a reactant side or which is product side, like, to be balanced. We just have to make sure in which in which compound have maximum number of atoms. Where there is maximum number of atoms are present, okay, so we should have to start it with that one. In that compound, select the element which has the maximum number of atoms. Using these criteria, we select Fe3O4 and the element oxygen in it. Yes, with 4. There are 4 oxygen atoms on the RHS and only 1 on the LHS. Yeah, that's true. To balance the oxygen atoms of oxygen at very first, okay, initial in reactant side only one, just because in H2O only one oxygen is there, and okay, and just iron, so there is only one oxygen in a reactant side, but at the product side there are 4 oxygen in Fe3O4. So we should have to balance, and to balance number of atoms of oxygen in reactant side, you should have to multiply water into 4 to form 4 number of oxygen atoms, and we have to like we get a balanced oxygen in our chemical equation. So okay, here in product side there are 4, so in reactant side we should have to multiply 4 to the water side, not at the base side, but we have to put 4 into the left side of water to just make sure the compound is exactly water. If we put oxygen, if we put O4 like H2O4, then this equation this compound will going to be changed. It's not going to be further to be a water one. So we should have to understand, we should have to put 4 at the left side just to the water. To equalize the number of atoms, it must be remembered that we cannot alter the formula of the compounds or elements. Yeah, this is true. Involved in the reactions. Just because if you like put it over here, they forms the different compound. Okay, so that's why we do not have to change that compound okay, by putting it number of atoms on it. So we should have to put for to balance the chemical equation, we will put at the left side of any one where we are preparing to balance that equation and balance the equation, balance the element. For example, to balance oxygen atoms, we can put coefficient 4 as 4H2 and not 4 H24O H2O4, yeah, or H2O whole 4. Now the partially balanced equation becomes Fe plus 4H2, it forms Fe3O4 plus H2. Here oxygen is balanced at the left side as well as the right side. Okay. Step 4. Fe and hydrogen atoms are still not balanced. Yes, pick any of these elements to proceed further. Okay, so pick any of the elements to proceed further. Iron is 1 at the left side, iron is 3 at the right side, hydrogen is 8 at the left side, and hydrogen is just 2 at the right side. So we should have to choose the more number of atoms to be balanced first. That makes you to convenient to balance the chemical equation. Okay, so we are going to start to balance the hydrogen atom, hydrogen element. Okay, here it is at the left side 8 hydrogen atom, and at the right side there are just 2. So we have to multiply 4 with hydrogen element over here, so to become 8 number of atoms in hydrogen element. Okay, let us balance hydrogen atoms in the partially balanced equation. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the RHS. Yes. So over here it's written like atoms of hydrogen at the initial time. There are in the reactant side there are 8, just because in 4H2O 4 into 2 it becomes 8. Okay, 8 number of hydrogen atom. In product side 2 hydrogen atom, just because H2 is present at the right side, that's why. And for to balance the atoms of hydrogen in this equation, in reactant side 8 is okay, but at the product side you have to multiply with 4. So we will have to put 4 in the left side of H2. Okay, we all get it. The equation would be what? 4H2O. Yeah. The total equation is Fe plus 4H2O forms Fe3O4 plus 4H2. Yeah, that's it. And 1.7, this is also a partially balanced equation. This is not fully balanced equation, this is also a partially balanced equation. So we should have to be make it a fully balanced equation. Okay, step 5, it says examine the above equation, okay, and pick up the third element which is not balanced. The third element is what? There are only three elements in that example. So the third element is iron, Fe. You find that only one element is left to be balanced. Yes, that is iron. Atom of iron at the initial time, there are one in reactant side, but at the product side, three, just because the compound is Fe3O4. So in product side, three iron is present. So we should have to multiply iron three times in the reactant side of their iron for to balance this. So to equalize Fe, we take three atoms of iron on the LHS. Okay, so we are multiplying 3 at the left side of iron. Okay, 3 Fe plus 4 is 2. It forms Fe3O4 plus 4 is 2. Okay, okay. Is this balanced? No, this is not totally balanced. But no, but why this is not totally balanced? Because we only balance the one by one atom. But is that true that this equation is finally balanced? No. So step number 6 is saying that finally, to check the correctness of the balanced equation, we count atoms of each element on both sides of the equation. Yeah, that's true. We should have to uh, like uh, like this is a audit. Like you have to check again, is this totally balanced? So okay, so we are going to it. 3 iron at the left side, 3 iron at the right side, with compound Fe3O4. Okay, that's it. 4 into 2. Okay, hydrogen is 8 hydrogen atom at the left side, and at the right side there are 4 into 2, 8 hydrogen at the right side. That's true. And with oxygen atom, there are 4 oxygen atom at the left side, and there are 4 oxygen atom at the right side with compound Fe3O4. Yeah, that's means all elements are balanced over here. Okay, that's good thing then. Then it becomes balanced equation. This is not a partially balanced. This is a totally fully balanced. So that's we called balanced equation. The numbers of atoms of elements on both sides of equation 1.9, okay, over here 1.9 equation, are equal. This equation is now balanced. Yes, this equation is now balanced. Yeah, we all know. This method of balancing chemical equation is called heat and trial method. Oh, what's the name of this balancing chemical equation is? What's the name of the method of this kind of balancing chemical equation? By using, we should have to start by starting like by the convenient form of using highest number of atoms in a compound. So what's the name of that method is for to balancing the chemical equation is heat and trial method. As we make trials to balance the equation by using the smallest whole number coefficient. Okay, what it means, bro? Using the smallest whole number coefficient. Okay, okay. As by a smallest whole number coefficient. I didn't get it at all. The whole thing, whole number coefficient. Oh, coefficient means the prior side. Like coefficient is 3 at here this example. 3 is the coefficient here. 4 is the coefficient of 4 is the coefficient of this water molecule, and here it is 1 coefficient of Fe3O4, and here it is 4 coefficient
of H2. And it says like what, a smallest whole number coefficient. That it means you don't have to like put like there, what I say, you have to multiply the total equation with 2. It becomes like 6Fe and 8H2O and 2Fe3O4 and 8H2. No, you should have to just divide by 2 then. If you write like this, like 6 iron, 8H2O, 2Fe3O4, 8H2O, then no, this is not balanced. You have to balance. Okay, I know you are, this is balanced, but in proper way you have to be write it in a smallest whole number coefficient. Okay, I think you got it, my point. Step 7 it says writing symbols of physical states. Oh, on the physical state, that means solid, liquid, and gas. And even two other states are even also present, like plasma and BEC, Bose Einstein condensate. But you should have to just, okay, you are just at class 10 level, so you have to don't think about other kind of thing. At your level you have to understand physical state at 3 level: solid, liquid, and gas. That's it. Yep. carefully examine Carefully examine the balanced equation 1.9. Okay, does this equation tell us anything about the physical state of each reactant and product? No, they didn't tell me about any kind of thing. What are the physical state of these some of the reactants and their products? No information has been given in this equation about their physical states. Yes, to make a physical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formula. Wow, that's great one. Okay, the gaseous, liquid, the gaseous, the liquid, the aqueous, and the solid states, okay, of reactants and products are represented by the notations. Like what, for gaseous you have to write the notations. Notation means that's the short form of their like something. Okay, so the notation of gaseous is, with bracket, with a small bracket you have to write G, and like open the small bracket, and then write G, then close the small bracket. Okay, and bracket with liquid. For liquid you have to use the notation L, and you have for the aqueous you have to use notation AQ. And what is aqueous, bro? What is aqueous? Aqueous is, it means combination of water and some other material, and it forms aqueous. For example, like uh, example like what I say, water plus salt is an aqueous. Water plus salt plus sugar is an aqueous. Water plus salt plus sugar plus lemon, you add lemon, then it also aqueous. Okay, and even with water plus glucon D, it's also an aqueous. Yeah, so okay, this is also an aqueous. And so as well as sulfuric acid is an aqueous. Okay, it's not a liquid. Liquid is just water. Aqueous is, it's a combination of other things. Sulfuric acid forms with like uh, sulfur and H2S, then oxygen. So sulfuric acid solution is a aqueous. Okay, HCl is an aqueous, it's not a liquid. Water is just a liquid. Okay, I think you got it, my point. Solid state, iron, iron, gold, aluminium. Okay, these are kind of things. Solid states of reactants and products are represented by notation. Okay, okay, G, aqueous, and the notation of solid is S, respectively. The word aqueous, AQ, is written if the reactant or product is presented as a solution in water. Okay, is presented as a solution in water. You know, like if I I just tell you the like told you, like sulfuric acid solution, by somehow water, there like water is also like present maybe, that's why it's also a aqueous form, like okay, uh, there's a liquid material, so that's why it's aqueous. Okay, the word aqueous is written if the reactant or product is present as a solution in water. Okay, the solution is which is present in water, that's an aqueous. Okay, and even with the absence of water, also present with like sulfuric acid is also a aqueous. It's not like a solid. It's not like a liquid. It's like a liquid, but in liquid, more specific, it's an aqueous. Okay, the balanced equation 1.9 becomes 3Fe plus 4H2O gas. Okay, Fe3O4 plus 4H2 gas. Okay, 1.10. Okay, note that the symbol G, okay, is used with H2O. Okay, here it is. This is the most important, iron, which is a okay solid. We all know, but water present in liquid state. Okay, at the normal water is liquid form, and the gaseous water, that it means it's a steam. Okay, that's a steam. The normal water temperature is like 21 degrees Celsius, 25 degrees Celsius. Okay, okay, this is the normal water temperature. Even at the winter time, the normal water temperature is 12 degrees Celsius, 13 degrees Celsius. It's okay. Okay, and 25 degrees Celsius. That's it. And but the steam, the gaseous water, the steam, more than 100 degrees Celsius. The temperature of that water is more than even 100 degrees Celsius. Okay, Fe3O4, which is a solid. Yeah, so this is a precipitate. H2 is a gas over here, hydrogen gas, that it means. Note that symbol G is used with water, H2O, to indicate that in this reaction, water is used in the form of heat over here. Oh my god, that's good. Usually physical states are not included. Okay, you have to notice or you have to understand the thing is, usually physical states are not indicated in a chemical equation unless it is necessary to specify them. Hmm. If somebody is like asking you to like write it down with the physical state of the chemical equation, then you have to give it to it, and otherwise there is no need to give it the like physical states of the chemical equations. Okay, I think you got it. Sometimes the reaction condition conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, okay, sometimes the reaction conditions such as temperature, pressure, catalyst. Okay, what are those things? What are okay? What are those three things over here? Temperature, what are these three things over here? It is temperature, pressure and catalyst, etc. But the reaction are indicated above or below the arrow in the equation. For example, carbon monoxide. Okay, this is a poisonous gas. Carbon monoxide, very poisonous gas that can kill people. Okay. Carbon monoxide gas plus 2H2 gas forms CH3OH. Okay. Carbon monoxide gas. But why we said carbon monoxide? Just because here carbon and oxygen. And in chemistry, so its written form is for one it's mono, for two di or bi, for tri for three, and tetra for four, and in chemistry one represented by mono, in chemistry 2 represented by bi or di, in chemistry 3 is represented by tri, in 4 in chemistry represented as tetra, and 5 in chemistry represented as penta, and 6 in chemistry represented as hexa. In chemistry 7 is represented as hepta. In chemistry 8 is represented as octa, and 9 in chemistry represented as no, known, okay, known, and hex, known, dec, and deca, and deca, or I think dec, maybe like that. You will going to understand or learn these kind of things some other days. Okay, so over here, sometimes, okay. So at the here it is 348 atm. So what's the unit, what their temperature unit is degree celsius, degree fahrenheit, degree kelvin. Okay, so pressure unit is atm, 340 atm, or pressure unit is bar, atm, and some other thing. Okay, pascal, and it forms CH3OH liquid. Okay, 6 CO2 aqueous, means 6 carbon dioxide aqueous forms, uh, it doesn't forms uh, in the combination of 12 H2O, that's a liquid, in the presence of sunlight, in the chlorophyll. Okay, oh. Here it is in photosynthesis chemical equation over here. uh, in the greenery part of plant, in stems, even in stems, in leaves, where there is chlorophyll is present, in the presence of sunlight with carbon dioxide and with the water, it forms glucose, and it produces oxygen, as well as water, and in this environment of our earth. Okay, it forms glucose. Their formula is C6H12O6. What's the formula of glucose? Yeah, that's correct. C6H12O6, and that's in aqueous form. And it also produce what? Uh, Oxygen gas, which is very very essential for our human, for to survive on this planet. Because be humans, be animals, be respire, all of the animals or all of the creatures on the earth survived in the presence of one of the element which is present on earth, that's called oxygen element. That's the gas. Okay, except one of the animal, mycoplasma, or you can say pplo, this organism is can survive even in the lack of oxygen. Yeah, that's the thing. Okay, here it also produce 6 oxygen plus 6 water in liquid form. Okay, using these steps, can you balance equation 1.9 1.2? Yes, actually this equation is already balanced. 6 carbon, okay, at the left side, at the right side 6 carbon, hydrogen is 24 over here at the left side, 24. Okay, glucose contains 12 hydrogen, and water contains even 6 into 2, 12, 12, 12, 24. At the left and right side both are equally balanced with hydrogen elements. Number of atoms is of hydrogen element is balanced in left and right side. And for oxygen at the left side, for carbon dioxide, oxygen have 12. Okay, 12 oxygen, then again 12 with water, 24 oxygen at the left side. Okay, 6 with glucose, 6 with oxygen, 12 with oxygen, 6 into 2, 12, 6, 18, 18 and 6, 24. Okay, here at oxygen is also balanced in the left as well as the right side. So this equation is totally balanced. Using these steps, can you balance equation 1.2 given in the next in the text here, in the text here? Yeah, using these steps, can you balance equation 1.2? 1.2 given in the text yearly. Okay, here where is the equation 1.2? Where is the equation 1.2? 1.2, 1.2, 1.2, 1.2, where we have to. Okay, so we should have to balance this equation. Mg plus O2, it forms MgO. So we should have to write 2 MgO, okay, at the left side of MgO at RHS. Okay. Okay, so 2 MgO, and the total balanced equation is like this: 2 Mg plus O2, it forms 2 MgO. At the left side 2 Mg, and the right side again 2 Mg, then left side again 2 oxygen, then right side again 2 oxygen. Yeah, that's it. 2 Mg plus O2, it forms 2 MgO. That's it. I balance the equations. So this chapter is finished. That's it. Bye bye. See you soon at the next chapter. Till then, bye. See you soon.